panel of Abraham Asset as the host, and we have Michael Riley as the co-host, and we have a special visitor, our Russell Cox. And this is Lunar Network Special Interest Group. We have a weekly hangout, and today's weekly hangout is identified by the Lunar Network SIG, weekly hangout LunarCubes 140513. That's the identification for today. And today's topic of discussion is the communication segment. And generally, we cover what is generally the scope that is within the network SIG's horizon. Okay, so we'll be joined by Michael, and Michael say hello to our audience, and we'll get started with it.
Hello, everyone. This is Mike Riley speaking to you from Gaithersburg, Maryland. We're wishing everybody well and looking forward to our communications segment discussion about how we're going to make the most of all the exciting things that are happening in the moon in the next decade.
All right, thank you for that. And Russell, as the guest, why don't you say hello to the audience?
Good day. So this is Russell Cox. I'm the CEO of Flexure Engineering, and we put on the Lunar Network SIGs and the Lunar workshops, and I'm looking forward to this work. Back to you, Abraham.
All right. So we're all ready to go, and we will get started with the presentation that I have put few slides. It's mostly for the discussion after we walk through the bunch of slides. Screen share, I'm going to do this one. Okay, start screen share. And all right. The Lunar Network 6 communication segment is the topic for today. And Abraham wasn't being the host, and Michael the co-host. We'll get going with what we got to share today. The Lunar Network has, for ease of identification and managing with the expert people we have divided into a space segment, communications, and ground segment. And that's the bigger context. And what within this segment we will be covering is the networking that happens within the space segment, and networking within the ground segment, and communication across ground segment and space segment. These all generally come under the communications segment, if we may call. And we also have outlined in elsewhere, these things will be aggregated by a regional network ops center in the ground segment, and the distribution control management will be in the US-based. And these things are to be followed in the next hangout that we'll be talking about. Now, let's also take a quick look at generally what we feel comfortable to identify or define as lunar network proximities, because most of them, almost all of them, are wireless in nature. There are no wires going. These radio waves are laser beams that go across. We will come into a range and the speed type of complexities that involve in the network communications. So in order to make a clear distinction, what we have is a close, near, and far definitions for now. The closed proximity refers to a few meters to a few tens of kilometers. And what this will encompass in terms of the nature would be spontaneous with low effort. It should get started. And we expect a lot of frequent chatter, and instances like docking, formation flying, etc. will be the typical nature of what happens in the communication in the close proximity. If you look at IEEE 802.11p, also referred as WAVE, these standards kind of talk about infrastructure for traffic on the ground. Okay, so these are all like road vehicles on the road and infrastructures like stop signs. They all will be enabled soon with a wireless communication protocol. We kind of say this is the type of a communication that we are likely to face in the space. Also, this will be a kind of applicable on the ground, on the surface of the moon, for prospecting with clusters of robots and rovers that may go. And this type of a close proximity will be omnidirectional, because the sender and the receiver may be positioned before, in front, or at the back, or on the sides. Okay. The next we go into the near proximity, which is somewhere between 10 kilometers to 50,000 kilometers. And these things refer to some distances like Earth, Moon's Lagrangian points L1 and L2 inclusive. Okay? The communication are likely to be occasional, mostly asynchronous events. We expect a low latency. The numbers will come eventually as we progress through these sessions. And many of them will also be relay resources. And the low duty cycle energy bursts, they are likely to be bursty, but they're generally low duty cycle. And these things are also kind of a comparable on the ground segment for backyard antenna, and certain things that we need to consider is orbital dynamics. That's like when you will be able to make a valuable connection or not, that kind of a context. Then when we can talk about far proximity, that's like a 50,000 kilometers to gigameters. These are distances like Earth to Moon type of distances, and also maybe L4, L5 type of distances. Very high accuracy pointing is required, and laser is a typical way of communicating that kind of distances. But currently there are lots of radios involved, and there's also kind of likely to extend to Ku and Ka bands. If you kind of think the complexity of direct positioning of antennas versus the satellite asset, you kind of compare something like setting up an antenna for receiving from direct TV, okay? And when we talk about the FAR, it's going to be a little bit tighter than that type of accuracies. And also we want to kind of throw in this picture, I haven't had time to kind of put the scribblies in it, but there are various types of coverages that we need to do from ground to orbital assets, and their aperture angle and the distances and the powers are to be considered as we go further into it. In the software stack, we have identified some of the things that we will have to deal with, and these are all very early in preparation type of a listing here. In the cislunar network, Earth plus long distances and the Moon involved, or any assets in between as a relay. These proximity A and the delay of the proximity A here refers to the CCS definitions of proximity. And in order to not clash with that, we also defined our own proximity like far, near, and close. Okay. However, looking at the proximity A definition, the delay of 10 milliseconds to 3 seconds and other orbital dynamics to be considered. The protocols we mainly anticipate is DTN and the TCP/IP stack. The TCP/IP stack, most probably we will be focusing around the UDP type of delivery mechanisms as opposed to TCP, because of the acknowledgement may not happen that fast enough for the protocol stack. And here is where the combination of DTN and UDP are likely to kind of be harvested most for our beneficiaries. Okay. Then there are other issues like IP version 6, whether should we step into it. And there are different implementations, and going through a gateway conversions of IP version 4 to 6 is another complexity we want to avoid. And unlike the 7-layer model that is discussed in the OSI, we will tend to go into a 5-layer model that is promoted by Cisco. Okay, and the next one we want to talk about is the connectivity at the media level, which is layer 0. We will have RF waves type of connectivity that will include UHF, S-band, KU, KA band, and some of those approved ones in the USA. Plus, it has much wider scope outside the FCC controlled territories. We believe that we will not be violating any regulations, international regulations, and wherever there are territories which allow us to have a higher throughput connectivity, we will switch the radio to those frequencies. These complexities will be evolving as we talk later. Microwave is another possibility, and we have not done enough study to talk about it, but in the idea of this SIG is we'll bring in experts who are specialized in these areas, and we'll see if that can be accommodated within the scope. And laser has been very recent innovations that they are able to demonstrate between distances like Earth to Moon, and we expect smaller versions in the CubeSat. There were a couple of projects that I have come across. In the 3U format, they're able to use optics for laser communication. And again, just to mention a note on the laser, we have planetary resources. They're able to use the optics that is designed as a telescope for prospecting asteroids. They're able to repurpose the same optics for laser communication when they turn the telescope back to Earth. So these are all some viable viabilities that we want to include in our scope of lunar networks. All right, and then there are things that happen specifically within the ground segment of the network, and as well as the lunar specific segment that will happen in the moon. Okay, and then there are communications that will be Earth to Moon direct. All these things will be covered in the coming sessions. Okay, so here is an attempt to see how we will lead the space communication enterprise can be built. We hope to partner with other leading people like Google and Telstra, and there are a wide range of terrestrial communication people nowadays looking at the space communication, and we were going to somehow align that we are not far away from their definitions, and we, even if they choose to be proprietary, we will try to make the interoperability possible. And in the here I had mentioned that the FCC has taken an opening step to proposal via some doc number that opens up the 5 gigahertz spectrum for ground communication. So this is a very big plus. And did I say FCC? I think it's ITU, and it's kind of coming down to be followed by FCC as well. Okay, and the Deep Space Information System, the Lunar Network, and the Deep Space Network in 2015. This is another topic which I have not dug adequately into its relevance, that it's identifying as an opportunity for small business to get opened up. The Deep Space Information System is the one primarily getting defined by Mike Riley, the co-host, that is runs parallel with the network system, and the Deep Space Information System would be the beneficiary of the physical implementation of the lunar network. Okay, the DSN is referring to the Deep Space Network, which NASA has, and there are avenues that will also get open to private enterprise. Okay, so in another presentation, we have identified what is the lunar web. By about 2020, we believe that some of our definitions will take effect, and these things currently exist in some form, but we want to kind of get that formalized into the scope of lunar web. And at the lunar web definition levels, these things enable identification of node-to-node communication and be able to set up a session, whether it's like open-ended session or like a closed full duplex session, is the way to go with the lunar web. We believe this web will be as the next level of infrastructure that will exist by about 2020. Having the lunar web established, it moves up the ladder in the services to lunar cloud. And lunar cloud essentially covers a service that may be requested at the surface of the moon, for example. And these will map to the simplicity that is available with terrestrial cloud system that is available on the Earth. So we basically take those cloud computing model and extend it to the lunar resources and assets and provide services through the infrastructure that we built as lunar cloud. These are essentially a set of large framework, and that will be continuously fostered, and the method of maintaining the sessions, and when it evolves up to the next level of cloud delivery of services, these things will enable authentications and certain types of metering the services and providing. These things will lead into the lunar network cloud services that we are anticipating it will be needed by about 2025 and beyond. So here what we offer is to start with a data transport where images that are captured or any other science analytics that is performed on the surface or asteroid, they generate huge amount of data, and how do we get them to where it is needed back down in Earth? That would be one nature of the data transport. And this class of service will have receive links and transmit links and end-to-end, and the service units will be metered like megabits per second in terms of throughput, and the quantity of data, it may be inclusive of data mules like mechanisms that carry gigabytes leading to terabytes eventually. The next interesting thing that we expect, that the provisioning of power to be delivered from one asset to another asset will be managed through the cloud services. These include like orbit to surface and surface to surface on moon. Okay. The service class may include solar reflectors using simple optic routers. For example, a set of constellation that's revolving around the moon may be pointing to a tower, and the tower may have optical mechanisms directly that can beam down into a pit where there's maybe a rover or mining crew of robots which will obtain power through those. And this is also possible to provide certain level of signaling over the power. Okay, for example, today we already have power metering that's happening in the utility sections in pretty much a large part of California and several states. If you look at power delivery through a light source. It's very comparable, and adequate amount of experiments and practical methods have been established already. And laser power delivery has been already demonstrated, and that includes already the signaling over power methods. Of course, the service units that we expect here will be in the watt and watt hour. Then we get into the compute services, like when substantial amount of data is captured somewhere by a cluster of space assets, we need to have substantial amount of computing done. So the payload that needs to come down can be filtered to the useful points of references. So such computes will exist similar to what we have like Amazon clouds or Google Cloud, or there are several other types of compute systems that's available. So these are the type of large cluster of compute services that we anticipate that will be existing on moon surface or somewhere in the space. And these provide cluster processing and phenomenal amount of mass storage that may be required, as well as needed for variety of needed computations. The compute unit today we have not determined, but it may map close to what Amazon does for billing and providing services. And then we come to the navigation services, very similar to the Earth GPS. We hope and we expect that there will be additional resources that may exist at L1, L2, some in the moon orbit, and some of them, some of the service needs may be typically to provide roving and rovers and robots that may be doing some useful mining or prospecting work. Okay. The service class here, we're talking about to identify that particular asset, where is it located, and if it needs to go someplace, how do you locate the target and how do you navigate to that target? Okay? Google Earth is a very good example today. If Google Moon provides that kind of a services pretty shortly, yes, we will not reinvent it, but we'll kind of make it available through the lunar network. And finally, the service units for providing navigation services will be very similar to how we do it in the cell phone location-based services. So these essentially are the ones that we're targeting, and that's all I have to talk about today. And when we can come back to ground segment, we'll be able to relate to how the space segment, which we already covered, and today we scope what is the scope of communication segment. And when we continue with the ground segment, they'll all start making complete sense. And that's all I have for today, and we will get on to the discussion. All right, I'm open. Michael and Russell.
So yeah, so one of the things, so we talked about the different segments, and then have you talked about how they're going to interact, or is that still today we're just laying out the kind of the taxonomy of the different layers?
That's right. Like I have done some preliminary work and substantial work, because we started with determining the scoping the overall the lunar network itself. Then the last hangout we had, we covered the space segment, and Michael did a pretty good job outlining those scopes as well as a follow-up. Then today we're talking about the communication segment, pretty much at the scope level.
Mm-hmm.
And then we have the ground segment that will be covered in the next hangout. Okay, and these end-to-end communication from a asset somewhere in the moon and somewhere a op center in the ground will be within the scope of what we are doing. And here, selective protocols and how do we identify, how do we position itself, when is optimal time to get direct communication, and when is the time to communicate via relay services, and what may be the cost of doing it or efficiency of operating the resources down on the earth. All that will evolve, and I believe typically to kind of get to that level, it may take more like a year or two.
It's 11:30.
Did I answer your question?
Yes.
Okay, thank you. Yes, Michael.
Well, one question I have
Yes.
is that in realizing a lunar network, particularly in the early stages, we're going to be relying on extended mission capabilities. For example, the main mission is done, and they still have some capabilities available. So how does that extra use of extended capabilities factor into the architectural concerns you're talking about?
Yes, and that's a very interesting piece. And you know, that's when the enterprise modeling makes it very practical and viable. When we talk about, for example, the simplest form I could kind of talk about the Amazon cloud services. So when you look at their product list, they have close to 40 products that they offer to the customers, and they cover at their end of the operating op center. They know they have assets of maybe 100,000 nodes that's located in Dallas, another 200,000 nodes that's available somewhere in the East Coast, maybe another 150,000 nodes that's available somewhere else near California or Colorado. So these are bit of a heterogeneous capabilities, some both in terms of compute, storage, and the special protocols for which they are optimized, and load sharing capabilities that happen at the enterprise level. So these things are done by discovery protocols of each of these assets that's within their cloud. So likewise, the heterogeneous nature of what we find will be very, very interesting and very, very, very sophisticated, to the extent that in the property list, which is a smaller version of the Java class modules or discovery protocols. So they contain a large, like depending upon whose class libraries we may model, we will have several of these defined in a meta language, and these capabilities of taking pictures, the camera capabilities, or a rover capabilities, or a robot arm capabilities. All these will be kind of described in a fairly intermediate higher level language, typically XML-based derivatives. And that will outline and also define somewhere with the, the dictionary of what the capability is, and that will include things like response times, how heavy the arm can carry, or what is the aperture of the camera there, or like the resolution of the CCD sensor there. all those kind of capabilities in a relevant form, ready for consumption, will be listed in capabilities mapping. And that's where the Ops Center that we build in the Earth is going to be very, very interesting. And to some extent, I also saw the military, when they kind of identify these soldiers with different capabilities, there are lots of lessons that can be imported from those type of networking as well. I hope I attempted to answer halfway at least.
Well, a follow-up to that is I know that you have Department of Defense and other agencies putting together enterprise models for their own systems and systems of systems. It seems to me that to make the lunar networks more real, we should have a enterprise model of the sort that you're talking about, perhaps at different levels of fidelity as time goes on. Is anyone putting together such a model, or is there some way that we could get somebody to fund us to get a reasonable level of fidelity with such a model?
Yes, that's where like some of the capabilities that Russell brings in terms of identifying the resources where they can support with both technical expertise as well as to some level some type of funding. Today in the enterprise, as we pointed out, the primary abilities centered around large data centers. But as the customers show up for fleet of vehicles, so they kind of develop that type of fleet capabilities, as well as the depends on, like, if, for example, take Hertz. Their fleet will probably run close to less than like sub-millions of rental cars and trucks and various kinds. And among that, what is available and what is doable on almost on a demand basis or almost on a schedule requirement basis, they have the systems in place that they can do that. So as we kind of identify, these are the models that we can pick and adapt. I'm quite sure Russell will be able to find the resources to make that part happen.
Well, I think we have a real strength in the modeling aspect of this. We have strengths in the enterprise modeling, where we can put together our systems models at a fairly high level, where we can talk about how capabilities and assets interact with each other. We also have a very strong technical simulation capability as well, and this is something that I know I have some a network and group of people that I've worked with before in both for DARPA and NASA's Constellation mission. So we have some of that engineering capability for doing enterprise modeling and the systems modeling as well, and those are going to be important for putting together a vision that people can start to gain some confidence in and start to believe that you can put together this lunar network in the time frame that you're talking about. However, putting together those models does require some care, and it does require some expertise.
Yeah, I think that's one of the functions of this group, is to kind of get out in front, because one of the aspects that led me to talk to Abraham and suggest we create this group is, for example, right now there are 3 orbiters in lunar orbit. And so one of the questions is, they're not designed for it, but what are the unused assets and resources they have that could be used if somebody else wanted to use them? And soon there'll be a Korean orbiter, an Indian orbiter, a Russian orbiter, and once we have 5 or 6 orbiters in lunar orbit, there could easily be at any given moment a fairly substantial amount of unused capacity of one form or another. Creating some sort of model that says, how do we plug stuff in, initially very heterogeneous, very ad hoc, and then growing into more structure and order, is going to be one of the key questions, both technically and from a human point of view. Who cares, who's interested? And then this leads into one of the things we're going to talk with Kennedy, KSC, on Thursday, And one of the things we're looking for and they're looking for is what would be a project that they could put a little money behind, a little resources behind that they have. And we talked a little bit about kind of the legal hurdles on all of this. And then the other, I think another one that might be good for them, I suspect one of their expertise is these very heterogeneous systems, would be to consider this part.
Well, modeling heterogeneous systems at different levels of fidelity is something that I think, again, is our strength. It's a systems engineering strength that we have, and we can draw on people who've done various kinds of modeling so that you can actually start to do some trades and start to define what we can do with that system. So maybe that's something that Kennedy or some others who are trying to think about what they could do next with these assets, maybe that's something that we can get them interested in.
Mm-hmm. Good idea, thanks.
Hey, Michael, I see small messages, almost some 13 chat messages. Any idea of how to make the chat appear?
Well, I brought up the chat app on the side. You know, it's that little blue and white thing icon at the top of my Google app bar on the side. And I've been typing in a few questions and a few notes about our conversation as time has gone on, capturing some of the things that you've said and also a point or two by Russell as well.
Oh, okay, thank you.
If you want to scan that and see if there's an interesting question there that you can address briefly, then that would be good. Or also Russell too. I don't know if Russell can see it.
Yeah, I just pulled that up. I was wondering where those were, and that's a good use of that. Do you get to store those questions somehow, or do we have to copy them out?
I have no clue. I would hope that it would show up underneath the video when it's on YouTube.
Yeah. Yep. So we'll have to explore that. Good.
I'm sorry if I interrupted the flow of thought. Michael, you were saying something about the opportunity that we discussed with KSC?
Well, it's just that we have this mission. We have this capability to model missions at different levels of fidelity. You know, using enterprise modeling tools, using other more technical tools as well. We have people. I know people, and I've worked with some folks before on modeling different missions. So if people are interested in figuring out how to put together or design different mission architectures using enterprise modeling tools, that's something that we can do.
Excellent. All right. I will definitely make that a point. This Thursday we have a small meetup with Kennedy Space Center. Would you have time to join us right back?
What time of day is that again?
It's like
11 Pacific, I believe.
No, I think 4 p.m. Eastern.
4 p.m. Eastern, so 1 Pacific?
Yeah.
And this is Thursday?
Yeah.
Yeah, on my calendar it's 11 Pacific.
11 Pacific? I will confirm. All right.
Okay, if it's 11 Pacific, then that works for me. 4 is a bit more difficult. I'd have to make some arrangements over here on my side. Okay.
Essentially, like I have put in the same presentation we did in one of the Hangouts, like the scope of the Lunar Network SIG. We're making a condensed version, and we can add your notes on it and share our part of what we do on the SIG and what all we can leverage the resources that they may be willing to extend to SIG.
Very good. Yeah, just let me know what time it is, and we'll figure out what level of interaction I can have.
Excellent. Okay.
So I just posted Bonnie's notes on what she'd like. It's kind of hard to read in the chat window. Can you explode these chats to be readable? Doesn't look like it. But anyway, yeah, Abraham, so you should get together with Mike, because it'd be very helpful to have you on that call.
Okay, great.
All right. So are there any other things that come up in the communication segment? Because like the communication segment itself will be three things, like the links at far distances, which are typically satellites, rovers. There are wireless assets, like the links specifically, and corresponding links in the ground segment. Okay, and if there are spontaneous dynamic networking that's happening in orbit or among all the space assets, that would be the communications around the space segment. So it's not very clear in my mind to put the right set of terminologies in it, but this is not anything new. Like it's always trying to group in a manner that it makes sense and it resides in the segment of interest where the expertise can be easily found and translated into the message and the payload equivalence. So that was my attempt to do today. And when it comes to the link specific, we'll have experts from JPL that they talk about their experiences with different types of radios, directionality. Then we'll also bring certain people who are experts in the orbital dynamics and identify which antenna, where do you point, where. And I'm quite sure NASA has so many people that you may already know. So that'll all be in the some of the subsequent hangouts that we'll have. And hopefully correspondingly, like your development of Deep Space Information Network, we can also kind of spend some time on it, like the software piece that will finally be from end to end. How do you do that? How late we may get? How accurate and without any loss of data we get? All that will be kind of hopefully captured by the parallel track that you are going to be developing called the Deep Space Information System. So after we kind of cover the scope of the ground segment, then we'll do a few rounds of drilling down into the Deep Space Information System as it pertains to information.
Okay, that sounds like a plan.
Okay.
That sounds like a plan. One thing that I get from your presentation today is just how heterogeneous and somewhat complicated the vision is. You have these three different regions of communication, the close, the near, the far. You have multiple heterogeneous elements that are going to be part of that. And I think you're getting at a degree of complexity that I don't believe that people have really worked on before, at least in the deep space context. They work really hard to try to keep things as simple as possible, and they still wind up with fairly complex systems. Now, there are probably other networking domains where you do get that kind of complexity, but I don't believe that NASA has really gotten into that with the remote space segments. This is, I believe, is another level of capabilities that we're trying to put together.
Yeah, and I think that it's a combination of one, it's an opportunity, and two, it's kind of ready or not, here we come. At Mars, they had at the peak, I think, 6 different three lander stations and 3 orbiters when Phoenix was on the ground, and that was kind of the first example of these heterogeneous, again, initially ad hoc and then later better designed, but still pretty heterogeneous and deep space networks of the kind that we're talking about. In the moon, you're going to very quickly have a lot more players, even with nobody trying. So, you know, like I said, there's already 3 orbiters on the moon, and 5 years from now, it's very easy to imagine that it'll be 5 or 6, and it will never go below that again. And so this very heterogeneous world where everybody's at least playing in the same pool, whether they're trying to play together or not, is going to be something that has to be handled between the, you know, in the 5 to 10 year time frame. And so it's both an opportunity and a headache.
Well put. I think that with the level of the discussion that we've had today, we're really ready to bring in domain experts and people who are going to be particularly interested in these different aspects. I think that we're there to bring in folks to help us discuss the different aspects of these questions that we're bringing up.
Good. Thank you for that, because that's actually one of the things that's coming up with Kennedy. And in fact, actually, the whole purpose of the call is they want to join some of our SIGs, and they want to know who should join which one and what does that look like. So yeah, so I sent you an email with the Bonnie's outline of the Thursday call, and so Abraham and Mike, you guys should think about how are you going to open this up, how are you going to roll it out, how many people are going to join early. Are we going to do like a monthly phone call plus the weekly, or are we going to try and wrap it all around weekly? So we'll talk a little bit more about that. Starting next week, we'll be doing a weekly SIG leaders call to start putting together a structure around the work you guys have been doing. Right now, I think there are about 4 SIG leaders, and each one has been doing something slightly different. So over the next few weeks, I want to come up with a kind of unified model, which allows the different SIGs to not be identical, but there's a core. Everybody's got a base camp, everybody's got a wiki, everybody's got a monthly call. Is probably what I'm thinking. It was the 3 components that are always the same, and then if people want to do something more different, then that's up to them and their group. So be thinking about that.
Yes, so that brings to another point I had with the meeting I had with creatine marketing. Okay, Mike, I might have earlier mentioned to you, Russell has hired quite a small but competent group here based in Sacramento. They're doing the web development. So while updating them with some of their needs and concerns, I also kind of having done lots of experimentation for managing this. They're very receptive, and they kind of now understand what would be the minimal and simplistic web presence that we'll have for the Lunar network SIG. And I'm currently experimenting with a platform called Wix, W-I-X, and they seem to have some preference to something called Weebly, W-E-E-B-L-Y. So I'm experimenting with both of them. At the minimum level, we will have a website and a website as well as a blog facility and a depository where we can have some of these files that we would like to keep between the inside members and certain things which may be visible for the general public. And these are something I'm also working on besides what we are doing. So as a point of note for our next conversation. All right.
It sounds good.
So, yep, sounds good. I think I'm going to have to wrap and get on to my next call. Yes. So good work, guys.
All right.
Good. Thanks, Russell.
Thank you.
Okay, so Abraham.